cubic polynomial has a leading coefficient of 1. It's known that p of 2 is 0, p of minus 1 is 0, and when it's divided by x minus 3, the remainder is 10. Find an expression for p of x in the normal cubic form. So first of all, we know that the leading coefficient is 1, so it's equal to x cubed plus bx squared plus cx plus d. Secondly, p of 2 is equal to 0, means that 8 plus 4b plus 2c plus d is equal to 0. P of minus 1 is equal to 0, means that minus 1 plus b minus c plus d is equal to 0. And finally, the remainder is 10 when divided by x minus 3, means that p of 3 is equal to 10 using the remainder theorem. P of 3 is going to be 27 plus 9b plus 3c plus d is equal to 10. 3 unknowns, 3 equations. We need to solve these simultaneously. If this was a calculator exam, we would substitute this straight into our simultaneous equation solver in the following form. If it was not, we would have to solve these simultaneously manually. Easiest approach to do that would probably be to take away in pairs to get rid of the d's, and then we would get a pair of simultaneous equations. Let's try and do that then. If I call these, let's call them equation 1, 2, and 3, so it's easier to refer to. I'm going to do, let's do 1 minus 2. 4b minus b is going to give me 3b. 2c minus c is plus 3c. Minus 8 minus 1 is minus 9. So that's a new equation. I'm going to call that one in a different color. I'm going to call that equation 4. I'm going to use that in a second. And then I'm also going to do 3 minus 2. 9b minus b is equal to 8b. 3c minus c is plus 4c. These cancel. Minus 17 minus 1 is equal to minus 18. And I'm going to call that equation 5. And I'm now going to solve these two simultaneously. I'm going to do that by simplifying them both a little bit. This one I'm going to make b plus c is equal to minus 3. This one I'm going to make 2b plus c divided by 4 is going to be minus 18 over 4, which is minus 9 over 2. Or minus 3.5, so minus 4.5. Slightly easier to deal with in this case. Combining those two then, I'm going to do 5 minus 4. 2b minus b is b, c minus c, minus 4.5 minus 3 is minus 1.5. So b is minus 1.5. Now that I know b, I can work out c by substituting into 4. So c is also going to be minus 1.5. And now that I know b and c, I can find d, maybe by substituting into 2. So I've got minus 1.5 minus 1.5 plus d is equal to 1. These are going to cancel out, so I just get d is equal to 1. So that has found me b, c, and d, which means I can write p of x is equal to x cubed minus 3 over 2x squared minus 3 over 2x plus 1. Hence, or otherwise, find the remainder when p of x is divided by x plus 3. So that means I'm now going to do p of minus 3, which is equal to minus 3 cubed is minus 27, minus 3 over 2 times by 9, minus 3 over 2 times by minus 3, plus 1. I need to calculate that. If it's a calculator exam, I obviously put that straight into my calculator. If not, I've got to work it out longhand. So let's assume I've got a calculator here. Substituting that in, I get minus 35. If you did have to do it longhand, you would have to manually work out that final step. So that's how we can use the factor and remainder theorems in a slightly more complicated problem where there are 3 unknowns that we need to work out.